So we're going to go ahead and today and continue looking about the ways in which you can understand the operations of the organization that you're studying. Last time we talked about time studies, and now we're going to move on into the list and look at process charts and bills of materials, etc. Now, in some of the things that we do as industrial engineers, we use symbols associated with the activities that are going on, and generally we use these 5 different symbols. In an operations process chart, we're going to be using both the first and the last, the operation and inspection. But let's look at the meaning of each of these. So an operation is represented by a circle, and it's generally thought of as something that sort of changes the form of the materials. So if it's a process, you might need to be adding some information to a document, or it can be actually doing machining onto it. So you can see examples here are driving a nail, mixing, drilling holes. The next one is transportation, and transportation indicates that you're moving something from one place to another. And these are the one good thing about breaking up all of the tasks into these 5 categories is they sort of have different meanings. Like often transportation is thought of as almost a waste because you're not really value adding it at all. And so you need to look at those particular things as very carefully when you're looking at it. So the examples here are moving it by a truck, moving on a conveyor, or moving and carrying something. The next is storage, and this upside down triangle indicates a storage. So these are things like putting things in inventory or putting them in stock or putting them away in a document. Storage is something that's a necessary thing to do. Obviously, you need to keep things in a place before they are processed. It's really the time that they're spending there that becomes the issue, or actually how much space is being taken up. The next is delay, represented by this big D. And this is actually the one that you want to be looking at most carefully to see if there's any ways in which you can eliminate the delays. This and the transportation probably are the ways in which industrial engineers try to look for improvements. So this can be waiting for an elevator, material in a truck waiting to be processed, papers waiting to be filed. There's a lot of ways in which you will be waiting that you want to be looking at. And then the last one here is inspection. So inspection often is thought of as a value added because you're adding quality to the process. So when you inspect something, it's a quality improvement aspect. But you want to make sure you're not doing it too much or you're doing it in the wrong place. So again, you know the aspects associated with inspection and quality control that you really want to do inspection closest to the operation, but not over inspect. So this really just shows you where those are occurring in the processes. So for an operations process chart, and you might want to refer to the operations process chart that's in the case study that I gave you on the table manufacturing. We're actually going to be using that case study a little bit in the next couple slides. But this looks at the big picture of all the operations necessary to make one unit of product. And again, I said this before, but there's only 2 symbols that are used, operation and inspection. So let's look a little bit more carefully. This is the operations process chart from that case study. It's really hard to see, but hopefully you have it in front of you so you can kind of generally see what's going on. There's some things I want to point out. The first thing is that all operations process charts move from the upper left to the lower right. So that's that squiggly line there indicating that things are moving from that side down to the bottom. So we'll be moving that way. Also, everything that's a horizontal line is indicated something that is made or processed for this particular part. Everything that's a vertical line is something that's processed. Everything that's a horizontal line is something that's purchased. Got those mixed up, sorry. But the purchase parts here, again, would be the clear shellac and the wood screws and the gun. And where the made parts are going to be the legs, the sills, and the tops. So you can see that the ones that are purchased have no processes associated with them. They could have an inspection, but in this case they don't. The other thing is that the item to the farthest right is considered sort of the base of the product. So in this case, the top is what's considered the base. Everything is processed and then assembled onto the top. And it's sort of a judgment call, and many of what you'll do when you create an operations process chart will be a judgment call. Those of you working with IME 223 students will have them create these process charts. They should be able to do that. And you should know how to do that. Like if they do it incorrectly, you will want to make sure that it's correct. The other thing is that you also, most companies probably don't have that, especially the smaller companies we're working for. It's possible that Haas does, but many of the smaller companies don't have that, and you might want to create it for maybe one of their main products. So looking a little bit more detail on this, this is the sills portion of it, and you can see that you have the times associated with it. Now these are the standard times. These are the times that you just had calculated on the standard time, the time study calculation. So those times will be filled in there, so you can see how long it actually takes to process a sill. And these have nothing to do with who does what. This is just actual time spent on the item. So the operations are indicated by a 0, and also these are unique numbers. So somewhere there's another document that indicates exactly what happens in 08. The name of that operation is plain to size. So you look at 08 and it tells you what kind of tools to use, the drawings that you're going to be using, the actual ways you're going to be doing this. So again, this is really not a detail of what's going on. This is an indication, but you also use these unique numbers. And the numbering system goes from lowest to highest when you're looking at that. And again, the inspections will show up as squares on here. And again, there'll be an inspection that'll be an I2 that you'll be looking for if you're curious exactly what happens in that inspection. But that time, you can see the time associated with that also. So that's a operations process chart. The next thing we're going to look at is a parts list. Now, a parts list is pretty simple. It's just a matter of, and this has nothing to do with the case study right now, but this is just a list for the airflow regulator. This is actually from IME 223, this parts list. You can see the parts list has on it, it has the part number associated with it. So these are unique part numbers associated with the pipe plug. All of these parts go into making up this airflow regulator. So it has the drawing number, so especially if this is made, or even if it's purchased, it might have a drawing. It has the quantity, and it has the material and make versus buy. Now these items, well, these two, are not always seen on a parts list. Sometimes they're there and sometimes they're not there. But you definitely would have a quantity, you would have a name, and you would have a part number as a minimum. Some of these other things, they would have to be some sort of reference associated with it, but the order is not always the same for every particular company that makes it. Something that looks very similar to a parts list is a bill of materials. And I know you've seen a BOM, and you've seen both the parts list and a BOM, but understanding the differences in the two is going to be important for you. So the differences, there's two main differences. One is that we have this column that's indicated the level. And those of you who have had IME 410 do understand that this level is associated with MRP. It's also associated with the assembly process. So these items that are level 4, they are assembled together into items that are level 3. 3 is put into items that are level 2. Level 2 items are put into level 1, which are then put into level 0. Level 0 is always the final product. So if you go back to the parts list, you can see there's no listing of the final product on here, and there's also no listing of the sub-assemblies. While here we have the body assembly and the plunger assembly, and these assemblies are listed. Now it's not clear here which parts go into which assembly. Like, does this assembly go into that, or do these go together? Some of these could go into this. So the actual way it's assembled is, you can't really tell that from the bill of materials. But it also has in here the drawing number, the unit quantity, and the make versus buy. Again, these items here are not always the same. Those are not always what shows up on a bill of materials. But what will always show up is these levels in the parts numbers. So looking again a little bit, I think I already did this, talking about the level and the sub-assemblies. Now what I'd like you to do right now is to go ahead and create a bill of materials for the white maple telephone table in the case study, and actually really make it look like this bill of materials. So that's what I'd like you to do right now.